when somebody consumes cyanide in proportion larger than that is desired, then there is a binding of these two and we get cyanohemoglobin. Now cyanohemoglobin does not allow the carrying of oxygen throughout the body, so immediately the respiration stops. When respiration stops, all other activities stop and there is cardiac arrest and person dies almost instantaneously. Our body does detoxification of the cyanide, a little cyanide, which is in the permissible level. How it does? Cyanohemoglobin to some extent hydrolyzes in cyanide ion, and that cyanide ion in the presence of an enzyme sulfur transferase converts cyanide into thiocyanate and that is passed out in the urine. Secondly, it is used in the synthesis of vitamin B12, that is cyanocobalamin. So cyanide is used in little proportions. So to counter that, antidotes are used, like, so when cyanide is risky, then there has to be some green benzoin method. So one scientist named Breslow, he introduced the thiamine hydrochloride as a catalyst to carry out this particular benzoin condensation. So how he did that? So in the presence of base, this particular proton is lost, H plus is lost. Remember, when H plus is lost, both the electrons remain with this carbon. Now this is very peculiar condition. This is called as halide. When nitrogen is having a positive charge and adjacent carbon is having the opposite charge. So this plus and minus, this combination is called as halide. This in fact gives carbene. The carbenes are these electrons come here and these charges come here, and the lone pair of electrons, they remain with this carbon. So carbene is generated. Since it is part of heterocyclic unit, that is why it is called as N-heterocyclic Carbene. Now this carbanion attacks the carbonyl carbon, electron moving like this. So it becomes O minus. So we have taken this H from here to here, and then in the subsequent step this H plus is lost, making this as a C double bond, and this electron comes to nitrogen. Subsequently this intermediate is formed. This is called as Breslow intermediate, wherein there is OH group and then here it is nitrogen. Now when the nitrogen lone pair of electrons attack to this carbon again, this electron will move towards carbonyl carbon, which was electron deficient. This electron will come here. So we'll get this product O minus and rest of the structure as it is. So here, like the previous mechanism, it comes here. So this will go here, like we can see, and nitrogen gets its lone pair of electron, and we will get PH, COH and CO and PH, that is benzoin, and this moiety gets converted into halide again, and this cycle goes on. So this is how green benzoin condensation takes place. There is one very important point, that thymine, that is one having nitrogen and sulfur, their selectivity is slightly lesser than triazole moieties. That we'll see in the reactions further. Application, that benzoin is converted in the presence of acids into benzyl, and in the presence of benzyl this undergoes benzyl benzylic acid rearrangement to give benzylic acid salts. Secondly, the enzymes like benzoyl formate decarboxylase in the presence of diamine diphosphate here gives 90% yield in 90% of EE, that is enantiomeric excess, of this product, wherein OH is coming out of the plane. So in this case, one can see the electron releasing group like Cl deactivates this unit for the attack by the nucleophile. So it is this which is being attacked by thymine diphosphate first, and then this unit attacks here. So we'll get this product. So one must remember that whichever is the first unit on which the carbanion attacks, that is going to be the carbonyl group of the adduct. And here the yield is 90% because we are using thymine. Thymine is nitrogen and sulfur. But when 3 units are used, 3 nitrogen, that is called a triazole unit. So here the yield is much more with high enantiomer selectivity. So let's come to our last part of our lecture. That here I have some questions. In the presence of this is N-heterocyclic carbene, one can think of cyanide only and try to find out the product. Likewise, take aromatic compound, aromatic aldehyde, in the presence of ketone but having trifluoromethyl group. Thirdly, intramolecular crossed aldehyde ketone benzoin condensation, and you will see in all the cases yield is very high, very high. So intramolecular, that means some cyclized product is going to be formed. And lastly, this is alpha ketoester. This is alpha position, alpha ketoester. In the presence of an heterocyclic carbene, it is going to get you the product. Now I wish you all to write. If you find it difficult, you can search these references, or else I have hidden these answers throughout this video. You can search it and you'll get the answer. With this, my special reference to this virus, this is causing huge damage to the humanity. So let us be careful. Please be safe. Thank you.